All right, so let's wrap up lesson 3 by talking about continuous functions and what makes them a little bit more predictable and more helpful really to us mathematically to work with. And the foundation for what we're going to talk about today is it's actually a theorem that's really important. And in calculus, there are a few that you want to make sure you remember what name goes with which theorem. And so this one is actually called the, let me make sure I say it just perfectly. It is the intermediate value theorem for continuous functions. Let me write it out actually for you here on our screen. So it's the intermediate value theorem. Intermediate value theorem for continuous functions. So just in case you wanted to know how to spell that, now you know. The intermediate value theorem for continuous functions. So everything we talk about in this video, which is going to be pretty short, again, all things considered, is part of the intermediate value theorem. Okay, so take a look at this kind of empty graph that we have here. I've purposefully created a graph that doesn't have any numeric coordinates on it. We don't want it to say 1, 2, 3, 4, 5. We want it to be kind of open-ended. So let's say that on this graph there is a point somewhere, it doesn't really matter where, and we're going to say that it occurs at x equals a, whatever that is. And then let's say there's another point up here. It doesn't, again, matter exactly where, but we're going to say that it occurs at x equals b. So what that means is that if this is a, then this would be f of a, assuming that that's what we're going to name our function f. So the x value is a, the y value, whatever it is f of a. And then we have b, and the y value, the height of wherever this point is, we'll call f of b. And we're writing it like this because we want it to be kind of abstract. We don't want to nail down our points to an exact location. So what the intermediate value theorem for continuous functions says is that if I know that our special function f that we're discussing here is continuous. Now, it has to be continuous or this isn't going to work. But if it's continuous, then I can guarantee that every single y value between f of a and f of b is going to be hit by this function. So we don't exactly know what joins point a f of a to b f of b, but it might be a nice straight line up here. I don't want it to be a nice straight line. Or maybe it's like really ridiculous and goes up and down and up and down and up and down. But if it's continuous, I know that it's going to hit every y value between the f of a and the f of b. It might go lower, right? It might go lower than that. It might go higher than that. It might hit each point 10 times or it might hit it only once. But if it's continuous, every point between a and b is going to be intersected. So again, practically speaking, that means if I know that there's some, let me change the color here, make it blue. If I know that there's some y value in here, we'll call it y naught. That's actually a symbol, it's a little subscript 0 that says there could be many different y values here, but we're going to focus in on our initial one, y naught, which is also just a great math joke. If somebody ever tells you not to do something and you don't want to listen to them, you just say, why not? That's a good one, right? No, it's kind of lame. It's all right. I have to keep myself entertained when I have to do this much math in my life. So anyway, okay, back to where we were. So if there's a y value, y naught, that has some corresponding x value, so let's call it c, I can guarantee that both this value and this value, I can find it on, that I'll be able to find it on our graph. There's going to be some point that's going to be, c f of c. It's going to exist where this is our mystery y value. Why not? So it's kind of, if you're worried that you're overthinking this, don't overthink it. It really is exactly what you kind of would take it as at face value. If you have a continuous function between one point and another point, it has to hit all the values in between as it goes through, because that's what it means to be continuous. If it's discontinuous, this is not part of the continuity. The theorem for continuity does not make a statement about discontinuity, but we can infer from it that a discontinuous function is not going to allow us to make those same predictions. And so it's going to be, if you could take nothing else away from this other than this one statement, this is the important part. It really matters to everything that we're able to predict about a function whether or not we can say that it's a continuous function, at least in a certain range, or a discontinuous function. Because if it's a discontinuous function, we're going to have to really pay much more attention to what's happening in the graph. All right, that's it. That's what we really needed to know about discontinuity and continuity, and about the intermediate value theorem for continuous functions. And you also got a free math pun out of it that hopefully you'll be able to use in your real everyday life. And I will see you in class to talk about the rest.